So with our variable, let's go back and see what we've got. So we have 400 square feet is how big the center is. So that's our limit is 400 square feet. And I want to know how many stations if there's 20 square feet. So I need 20 square feet for each station. So 20 square feet times the number of stations needs to equal 400 square feet. Okay. Now, how many terms is on the variable side? So here's our variable. There's only one term. Notice there's no addition or subtraction. One term. So now we need to do opposite operations in order to move the 20 away from the x. This is 20 times x, so divide. Divide both sides because this is an equation. So if you do something to one side of the equation, you will have to do the same thing to the other side so they remain equal to each other. 20 divided by 20 cancels to 1, leaving the x. And 400 divided by 20 is 20. So they can put 20 computer stations into this new computer center in the space that they're given. Okay, so these have been one-step equations. Sometimes they're a little more complicated than that. Let's try and look at these last two. So we have a plumbing emergency and we need a plumber. The cheapest plumber charges $80 per hour plus a house call fee of $45. The bill came to $325. How long was the plumber at your house? Okay, think back to all of our translating words here. So $80 per hour that's we want to know how many hours is the plumber going to be there. That's our variable. We don't know how many hours he's there, but it's $80 for each one of those hours. Okay, so the way we would write that is it's $80 for each hour. Okay, then he says, oh, plus, well, that'd be a plus sign, a house call fee of $45. So not only are you being charged for the hourly fee, there's also, he's just going to charge you $45 because he came to your house. And our whole bill is $325. Okay, this is a two-step equation. There's two things that have to be done in order to isolate our variable x. So notice we have two terms on this side, and here's our variable that we're trying to get alone. So you have to move the other term away from the variable before you're able to solve for it. So this is plus 45, so we're going to subtract 45 from each side. And this is going to cancel to 0, leaving 80x. Okay, then 325 minus 45 is $280. Okay, so what this is saying is $80 an hour equaled $280 just for the hourly fee. So to isolate our x, it's 80 times x, so you do the opposite, 80, divide by 80 on both sides. These cancel to 1, leaving just an x. Now, previously I was saying, hey, we just left this as a fraction, but we are talking about time here, and time doesn't have to be whole hours. So I'm going to take in my calculator, and I'm going to put in there 280 divided by 80, which is what my problem says here, equals 3.5. So what does that mean? That means the plumber was at the house for 3.5 hours. Okay? All right, one last one. This is Mr. Thompson purchased 6 concert tickets for a total of $320, including a $20 fee. How much does each ticket cost? Okay, so we know the total cost is $320. Okay, he bought 6 tickets, but I want to know how much does each ticket cost. So 6 tickets times some amount of money plus $20 in taxes. Okay, 2 steps. We have 2 terms here. We're trying to isolate the x in this term, so you got to move everything else away from the variable before you can solve for the variable. This is plus 20, so let's go ahead and subtract 20 from both sides. and I'm going to have 6 times some dollar amount equals $300. Okay, because we bought 6 tickets times however much they cost, and it was $300. So this is 6 times x. Do the opposite to isolate it. 6 divided by 6. Do it to the both sides to keep our equation equal. The 6's cancel, leaving just the x on the left. And then we're going to take our handy dandy calculator. 300 divided by 6 is, it was $50 a ticket. Okay. All right. Hopefully that was helpful. Let me know if you have any questions. See you in class.